Good afternoon, students. I would like to welcome you to the class of mathematics. Today we are going to start new topic, what we call the logarithm. But before it, I would like to remind you, make sure you subscribe on my YouTube channel, what we call Sanfaume Online. Make sure you do it in order to get more tutorial videos concerning with mathematics subject. Okay, first of all, what is a standard form? Standard form is a writing of a number in form of a times 10 exponent n, in which that a must lie between 1 up to 10. It means 1 must be less or equal to a and also less than 10. Okay, and that n is any integers. It is 10 like a exponent, as you see here. This is a times 10 exponent n. So n is exponent, will be any integer. But you also have to note that this standard form sometimes is what you call the standard notation. So when you hear standard form, that is a standard notation. It's another name of a standard form. Okay. What is the meaning of a? What is the meaning of this one? A times 10 exponent n. What does it mean? This a, it's supposed to be the certain number which lie between 1 up to 9.999. Don't exceed 10. Don't exceed this one. It's supposed to be between 1 up to 9 point something, not 10. Because when you write 10, this 10 is out of our boundary. It's supposed to be less than 10. But also, this a, it can't be equal to 0. It's supposed to be any number which lie from 1 up to 9.999, something like that. So simply I can say, when you write in the form of a times 10 exponent n, your value of a must lie between 1 up to 9.999, something like that. Okay, let us check the example question concerning this one. Okay. For instance, you want to write this one into standard form or standard notation, because standard form is that standard notation. Another name of a standard form. Okay, it is 24571. Yes, this number we need to write into standard form. But to write into a standard form, firstly, if a number doesn't have any decimal, for instance this one doesn't have any decimal, so you have to introduce decimal 0 here. After there, you have to shift the position of your decimal in order to get the smallest number which lie between 1 up to 9.99. Okay, let us check it. I'm gonna shift this decimal from here up to here. Let me read my number when the decimal is here. When the decimal is here, my number will be 2457. This is still, it is greater than 10, doesn't lie between 1 up to 9. So you have to shift it again from here, direct, from this point direct up to this point. Okay, so now assume we have a point here. Read your number. Your number will be 245.71. Still this 245, it is greater than 10, so we're supposed to shift again. Okay, let me shift from here up to here. Okay, so now my decimal is here. Read my number. My number now will be 24.571. Still 24, it is greater than what? It is greater than 10, so you have to shift again from this one up to this one. Wow, yes. Now if you put a decimal there, your number will be 2.4571. This 2, it is small number. It lie between 1 up to 9. Therefore, I can say this one is the best to be a standard form. It deserves to be a standard form. So now I can write my answer. This one in standard form will be equal to 2.4571 times 10 exponent. Exponent what? It depends on the steps you shift. Okay, how many steps I'm shifting from this one? I will shift from first step, second step, third step, fourth step. Nearly shift this step only. That's why here it's supposed to be exponent 4. So at the end of the day, this one will be your answer. It will be 2.4571 times 10 exponent 4. This one is what we call the standard form of that number. I think you understand. Okay. That was the first question, like this one. We did it. The second question, it is a thousands. I think the same as the previous. The thousand doesn't have a decimal, so you have to introduce a decimal here, decimal 0. Then after there, you have to shift this one. When you shift this one to this point, your number will be 100.0. This 100, it is still greater than 10, so you have to shift again. Your decimal, when it will be here, your number will be 10.0. That number still is not required because value of 8 is supposed to be less than 10. So shift again to this one. Your number will be 1 point something. This one, it lie between 1 up to 9.99. So you have to take this one. So you're supposed to take 1.0. So 1.0 times 10 exponent towards how many steps do you shift? First step, second step, third step. You shift 3 steps. That's why times 10 exponent 3. This one will be the standard form. Okay, let us check for the question number C. This one. It is 245.61. 245.61. We need to write into standard form. As usual, this one already have a decimal here. Tayari tunayo decimal. Kwa hiyo tunataka kufanyika ni kushift. Okay, we have to shift this decimal position in order to get the small number which lie between 1 up to 9.99. Between 1 up to 9.9. Okay, let me test it. So when I shift this one to this position first, my number will be 24.567, like this one, 24.561. Okay, this 24 still it is greater than 10, so you have to shift again in order to get number which is less than 10. Okay, let me shift again from here up to here. Okay, now my decimal is here. Let me leave my number will be 2.4561. Now this is 2 point something. 2 is less than 10, so this one it can be a standard form. So this number in a standard form will be equal to 2.4561 times 10 exponent towards how many steps do you shift? First step, second step. I'm shifting 2 steps. That's why times 10 exponent 2, something like this one. Okay, are we together, students? That is what you are supposed to do. Let us continue. Clear everything? Okay, for this question now, it is quite different from the previous question. Now we need to convert this 0.0045 into a standard form. You have to check at this decimal. This number already have a decimal, so there is no need of you to introduce another decimal because this number already have a decimal. Okay, you friends, you're supposed to make sure that the value of a in a standard form, it can't be equal to 0. Check at this one. Standard form always written in form of a times 10 exponent n. This value of a, it can't be equal to 0, and also it is supposed to be less than 10. But when you look at here, this is 0. It is 2. It can't be a standard form. This is 0, it can't be a standard form. And when you shift to this direction, there is zeros, so you can't find a standard form. But when you shift to this direction, there is zeros, but there is some non-zero number. So you have to shift to this side in order to get certain non-zero number, and not this side, because for this side, there is no any non-zero number. There is zeros at all. So we have to shift from here and to this direction. Okay, let us go on. Okay, let me shift for the first step from here up to here. My number will be 0.0000, 0.045. Okay, this is 0 point something. Still, it can't be a standard form. So you have to shift again from here up to here. My number still will be 0.45. Still, it is not a standard form. So you have to shift again. This one. Now it is 4.5. 4.5. This 4 is less than 10, and this 4 is not a 0. That's why it can be a standard form. Now I can write my answer will be equal to 4.5 times 10 exponent. How many steps do you shift? First step, second step, third step. 3 steps, so times 10 exponent 3. But you also are supposed to put in your mind that when you shift from decimal position to this direction, your exponent is supposed to be negative, and when you shift from this direction to this direction, your exponent is supposed to be negative. So since we shift from this decimal position to this direction, our exponent actual it's supposed to be negative, like this one. Put it in your brain. From this decimal position, assume this is your number line, then when you shift this decimal position to this direction, actual your exponent is supposed to be negative. And also when you shift from this decimal to this direction, like this one, your exponent always it's supposed to be positive. Do not confuse. By this reason, my exponent here is -3 because I'm shifting this decimal position to this direction. Are we together? Yes. Thank you for your cooperation. I'm done for it. Let us continue. Okay, take your notes. Like I said before, I think you understand about it. Let us shift. Okay, so now for this one, it is a question number 2. We need to write the following in numeral. Write numerals of each of the following. First one, this one. What is the numeral of this one? Okay. This is 4.8 times 10 exponent 3. We need to write the numeral of this one. To write the numeral of that one, first you have to consider this exponent. It is 10 exponent 3. Okay, think about 10 exponent 3. This one is equal to what? Okay, this one, I know that is equal to 10 times 10 times 10 from the concept of exponent. Okay, but this 10 times 10 times 10 is the same as thousands when you multiply it, right? So now you're supposed to plug these thousands to your question. The question says that it is 4.8. This one, it is 4.8 times 10 exponent 3, but 10 exponent 3 is equal to 1000. So now your solution will be like this: 4.8 times 10 exponent 3, but 10 exponent 3 will find equals to 1000, so times 1000. Okay, multiply this one will be equal to this one. I'm done for it. So this one is a numeral of that standard form. Okay, so instead of writing this one, you can write only this one. This is a numeral of that question. I'm done for it. Let me shift it to the second question. Question number B. Question number B, now I have this one. I need to write in a numeral form. Yeah, this is 3.5 times 10 exponent -6. Okay, this is exponent -6. We have to consider this exponent -6. What is it? Okay, let me show you. What is this exponent -6? This 10 exponent -6, actual, this one will be equal to 1 over 10 exponent 6 according to the reciprocation. If you have a certain number and a negative base like this one and a negative base, that number will be equals to 1 over that number and a positive base like this one. So put it on your brain. Let me repeat something here. I know some students didn't understand it well. I said that we're supposed to consider that 10 exponent -6. This 10 exponent -6. 10 exponent -6. This 10 exponent -6 is the same as 1 over 10 exponent +6, right? According to the laws of exponent. Okay, if that is the case, this 1 over 10 exponent 6 will be equal to 1 over, we know that 10 exponent 6 is the same as what? Same as this one. The same as 1 million, because when you take 10 times 10 times 10 times 10 up to 10 exponent 6, we'll find 1 over 1 million like this one. Okay, but this 1 over 1 million will be equal to, when you divide, you will find equals to 0.00001, something like this one. So what next? This one is a value of 10 exponent -6. It means refer from your question, then you plug the value of 10 exponent -6. Our question says that we need to write 3.5 times 10 exponent -6. Okay, let me write 3 0.5 times 10 exponent negative 6, but this 10 exponent negative 6 is equal to this one, so you have to plug it. Now b equals to 3.5 times 10 exponent negative 6 is same as 0.0000000 1, 2, 3, 4, 5, 1. Yeah, something like this. Okay, so now multiply this one times this one, you'll find the final answer, which will be equals to 0.00123670 1, 2, 3, 4 0, then 1, 2, 3, 4, 5, 6, 7 1, 2, 3, 4, 5, 6, 7 equals 0.00035 will be equal to this one. 1, 2, 3, 4, 5, 6 0.035. When we work with the decimal place, 1, 2, 3, 4, 5, 6, 7. As you see, this is 6 and this is 1 decimal place. So when you come to find 7 decimal places, it is correct. Okay, so important things is that you're supposed to check out exponent first. Classify your exponent, then you will finalize something. I think we're done on it. Let us shift to the second part. Let me shift to the second part for this question. Oh, which question now? For this one, we did it. Then, wow, this note. Take your note then. This one. Okay, from these notes, positive exponent under the base 10 shows the place value of the given number. The positive exponent under the base 10 shows the place value of the given number. What does it mean? For instance, you have 10 exponent 1. This one is 10 and a positive exponent, as you see here. 10 and a positive exponent, which is positive 1. This one will be equal to 10. And when you have 10 exponent positive 2, this one will be equal to 100. Kwa hiyo kumbe tulivyokuwa tuna exponent 1 tulikuwa tuna 0.1, tuna exponent 2 tulikuwa tuna 0.2. Kwa hata tukiwa tuna 10 exponent 3 tutakuwa tuna 1 and 3 zeros. Umeona mchezo kwamba exponent will find the number of 0. Since we have exponent 1, we have only 1 0. 10 exponent 2, we have only 2 0. 10 exponent 3, we have only 3 0. Right? But this one is for the positive exponent and a base 10 and not otherwise. This is for positive exponent and a base 10. So even if you have, let's say, even if you have 10 exponent 12, still this one will be equal to 1 and 0, 12. 1, 2, 3, 4, 5, 6, 7, up to 0, 12. So now it will be equal to 1 exponent that one. Even if you have 10 exponent 20, it means this one is equal to 1, then 20 zeros. 1, 2, 3, 4, up to 20 zeros, something like that. So this exponent, positive exponent and the base 10 will find the number of zeros from the given number. The positive exponent and the base 10 will define the number of zeros from the given number. That's why I've said here. That's what I've said here. The positive exponent under base 10 shows the place value of the given number. That's why exponent 1, we have 10 because this is 1, we have only 1 0. 10 exponent 2, you must have 2 0. 10 exponent 3, you have 3 0. 10 exponent 4, you have 4 0, like that one. Even if 10 exponent 12, you have 1 is 12 zeros, right? But this one for the positive exponent, as you see here. How about the negative exponent? We shall check it here. Okay, for the negative exponent under the base 10 shows the decimal places of a number. So for the negative number under base 10, this one will show the the decimal places of the given number. For instance, when you have 10 exponent negative 1, this means the decimal place here is only 1, so you can write 0.1. And also, if you have 10 exponent negative 2, it means this negative 2, it is a decimal place. So now you have two decimal places, 0.01. Have you seen that one? And even if you have 10 exponent negative 3, this negative 3 shows the decimal place, 3 decimal places. So this one is equal to 0.00, then 1, 3 decimal place. When you count, you will find this is 3, 1, 2, 3. That's why exponent is negative 3. 1, 2. That's why exponent negative 2. Only 1. That's why exponent here is negative 1. So negative exponent and the base 10 will show the decimal places of the given number. So even if we have, let's say, even if you have 10 exponent negative 12, this means you must have 12 decimal places. This is exponent 12, exponent negative 12. So you must have 12 decimal places. At the end of the day, 1 here. So 1 is a constant. 1 is a constant for all of it. Let me show you to the paper. Okay, I will say this one, 10 exponent negative 1. Since it is negative 1, the decimal place is only 1. That's why it is 0.1. 10 exponent negative 2. Since the exponent is negative 2, that's why here you must have 2 decimal places, as you see here, 1, 2. This is 10 exponent negative 3. Since it is negative 3, you must have 3 decimal places, as you see, first, second, third. This is 10 exponent negative 4. So negative 4 shows there's 4 decimal places, as you see here, 1, 2, 3, 4. Actually, the last digit is supposed to be 1. You have to understand it. So even if 10 exponent negative 12, this one will be equal to 12 decimal places. So when you count, this one will be 12, and the last digit, it's supposed to be 1. The last digit is 1. That is a constant. Okay, I think you can beat it. Put in your mind for the negative and the positive exponent for the base 10 number. Okay, example questions. Calculate the following and give your answer in standard form. The first question is this one, second question is this one. From the first one, 7 times 10 exponent 2, 8 times 10 exponent 4. This one doesn't have any sign here, means there's multiplication. So we can write 7 times 10 exponent 2. This one times 8 times 10 exponent 4. You have to collect those with a decimal, and those you have to collect those with the exponent and those without exponent. This one doesn't have exponent and this one doesn't have exponent, so you have to collect them as you see here. And also this one have exponent and this one have exponent, so you have to write them together as you see here. Then from there, when you multiply this one times this one, you get 56. This one times this one, you have the same base different. You have the same base difference exponent, so you have to sum up exponent. 2 plus 4, so 56 times 10 exponent 6. Okay, this is the answer, but we're supposed to write our answer in a standard form. How to write this number in a standard form? We're supposed to consider this 56. Okay, this 56 in a standard form will be equal to 5.6 times 10 exponent 1, as you know it. Okay, but our question said that 56 times 10 exponent 6, so you have to plug the value of 56 there. So when you plug the value of 56, you will find equal to 5.6 times 10 exponent 1, then times 10 exponent 6, as you see here, then times 10 exponent 6. Okay, from there, this is 10 exponent 1, this is 10 exponent 6. You have to sum up, because when you multiply the same base, you're supposed to sum up exponent. So this one plus this one will get 6. So 5.6 times 10 exponent 7. This one will be the answer in a standard form. For the question number B, I think the same applied to the previous. You can try yourself for these questions. Too simple. The same as the previous question. Let me shift. Okay, for this one, you need to calculate the following and give your answer in standard form. I think almost the same as the previous. You're supposed to solve it as the previous question. Okay, this one, the first question. 4 times 10 exponent 8 divided by 5 times 10 exponent 5. Okay, you can separate it, this one, then this one, then this one. At the middle there's multiplication. So when you multiply this one, we'll find equal to this one. From there, this is 4, this is 5. When we divide, we'll find 0.8. Then this is 10x.8, this is 10x.5. To divide, if you have the same base, you're supposed to subtract exponent, so it will be 10x.8 minus 5, because we divide with the same base. So the same base you're supposed to subtract in the division of exponents. So 0.8 times 10 exponent 3. When we subtract here, we'll find 3. Okay, so now this is a correct answer, but it is not on standard form. To write this answer in standard form, first we're supposed to write a standard form of this one. After getting the standard form of this number, then multiply by this one. Let me help you how to find standard form of this 0.8. 0.8. You have to write this number into standard form. Will be equal to this one, will be equal to this one. Okay, you have to shift this decimal up to this point, right? When you shift this decimal up to this point, now it will be 8.0, because there is no any number here, so I can assume there is a 0 here. So it will be 8.0 times 10 exponent. How many steps do you shift? Only one step, so 10 exponent 1. But since I'm shifting to this direction, my exponent is supposed to be negative, so 10 exponent negative 1. But 8.0 is the same as 8, then times 10 exponent negative 1, because this 8.0 is the same as 8 at your. Okay, so this one is a standard form of this number 0.8. So now you have to refer from the question. Instead of writing 0.8, you're supposed to write its standard form, and also you have to multiply it by this 10 exponent 3. You will find the answer. Okay, you can try it. Then from there, for the question number B, this one the same as the previous question, just to separate. You have to separate this one, then this one. Okay, the first part will be this one, which is equal to this one. The second part will be this one, which is equal to this one. At the middle, there is multiplication, because when you multiply this one and this one, you will find equals to this one. Okay, then from there, the same as the previous. This one and this one, you can divide, you will find 242.4. This one and this one, it is division. Since we have the same base, we're supposed to subtract exponent, so it will be negative 5 minus 2. We will find equals to negative 7 here. From there, now we have to write the answer in standard form. You can write it as I said before. After writing this one in standard form, take your answer, multiply by this one as seen from the tutorial sheet. It is very simple. You can try it also. Yeah. Okay, the last slide, it is exercise. So take your time to finalize this exercise. It is yours. So take your time to finalize it. Okay, what I want to say, your students, you have to study hard, because situation is worse, so you don't know nini kitatokea hapo mbele. Leo tunaambiwa tu tunasoma kwenye mtandao siku zote, kwa hiyo jaribu kuizoea hii program. The last, do not forget to subscribe on my YouTube channel, what we call Some Form Online. Goodbye.